Once we know some of the basic features of a vertebra, we can move into the different regions, cervical, thoracic, and lumbar, and look at differences in the vertebrae found in those regions. So we're going to begin with the cervical vertebrae that are found in your neck. There are 7 of these vertebrae. We give them letter number designations, C1 through C7. There's 3 of them we're going to learn have other names to them, like C1 being the atlas, C2 being the axis, and then C7 being the vertebra prominens. C1 is known as the atlas because of the mythical god Atlas who holds up the earth. Just as if the atlas here, the C1 vertebra, holds up your skull. So the skull articulates with the atlas using the occipital condyles attaching to these superior articular facets. A facet is a smaller flat surface for articulation. If you notice, the atlas does not have a spinous process. It has what's known as the posterior arch. So no spinous process. What it does have are 2 extra foramen known as transverse foramen. And in fact, all 7 of these are going to have that transverse foramen, although it's very difficult to see them all on this picture. So C1 is the atlas. C2 is known as the axis because it has a structure known as the dens. The word dens actually means tooth or tooth-like process. It's also commonly called the odontoid process. That odontoid or dens forms what's called a pivot joint. A pivot joint in the body allows a structure to rotate. So when you rotate your head side to side, when you're shaking, no, that right to left rotation is done because you have a pivot joint between the atlas and axis. That pivot joint is specifically known as the atlantoaxial joint. In some instances, with extreme trauma to this area of the body, the dens axis can penetrate into a region of the brain known as the medulla oblongata. This type of injury is typical in severe whiplash and can cause immediate death because the medulla oblongata controls your cardiovascular system as well as your breathing. So that dens is pretty important structure to understand, not just what it might do in a severe whiplash, but also that it forms a pivot joint. If you look at the next 4, C3, C4, C5, and C6, they're going to look very similar. We call those the typical cervical vertebrae. Then you get to C7, and it has a name, vertebra prominens, because of this very prominent spinous process. And that prominent spinous process can be palpated on the surface of the body to better identify where C7 is located. Let's look at a little more detail with the atlas, a typical vertebra, and then we'll look at the axis. Here we have the atlas. We are looking at the atlas from above, so this is a superior view. We notice that it does not have a spinous process pointing posteriorly, but instead just has what's known as the posterior arch. It has an anterior arch that does not have a body. So there's no body on the atlas. What's believed to have happened is through evolution, the body of the atlas was donated to the axis and formed the dens. Here we see the 2 extra holes on each side, transverse foramen. we see the large vertebral foramen, and we see the superior articular facets for the occipital condyles to articulate. Over here we have one of these typical cervicals, so this would be more akin to C1, C3, C4, C5, and C6. The vertebral foramen tends to be more triangular shaped as opposed to round like many other vertebrae. They have the extra two transverse foramen. They have bodies that become larger and larger the further down you go. And they often have what's called the bifid spinous process, where the spinous process splits at the end. So this is what a typical cervical vertebra might look like. Here's the axis, a couple different views, a superior view and a lateral view. You'll notice that lateral view really gives you a good idea of what that dens looks like, projecting up from the axis. So you have the dens, you have transverse foramen, you have a spinous process, and you form that pivot joint with the atlas. Next region, we look at the thoracic vertebrae, T1 through T12. There's two major differences that you see with thoracic vertebrae other than the fact that they are larger than cervicals, and they're going to get larger and larger as we go down to T12. But you'll notice there's a lot of smaller facets or facets for rib attachment. So we have 24 ribs total, 12 pairs, and each pair will articulate with the thoracic vertebrae. So you're going to have these little facets, or the little facets that are on the body are known as demifacets. So that's a major difference between thoracic vertebrae and any other vertebrae, in that they have facets for rib attachment. The next major difference, and you can't tell that well here, but the spinous process will typically project inferiorly, especially in this middle area of the thoracic region. So the spinous process doesn't point straight back, but it points downward. You'll notice that the body will sometimes have two facets. So you might have two ribs making contact with this single thoracic vertebra. When that happens, we call those demifacets. Lumbar vertebrae are the largest, more weight to hold, L1 through L5. So they're going to have large, thick bodies to bear that weight. They're going to have thicker intervertebral discs to help bear that weight. They're going to have shorter but blunt-ended spinous processes. And obviously they're going to be the largest of the vertebrae. Here's a good catch-all of all the little differences between the three typical vertebrae: cervical, thoracic, and lumbar. The obvious difference is that they progressively get larger. So lumbars being the largest of the three types. The cervicals, I'll remind you, have the two extra transverse foramina for blood vessels. There's an important blood vessel that goes up your neck and supplies blood to your brain. It's known as the vertebral arteries. Those arteries, along with your carotid arteries, deliver blood to your brain. The thoracic vertebrae have spinous processes that are usually very long and project inferiorly. So they project downward. Now you don't see that in this view because this is a superior view. But that spinous process will point downward. Another big difference you see with the thoracic vertebrae is the presence of articular facets for ribs. You'll find them on the body, right here. You'll also find them on the transverse processes. There's a slight difference between the position of and the direction of the articular facets. You'll notice here that the superior facets are facing medially. So that's just a minor difference there. And then obviously the size of the intervertebral discs have to be much thicker the farther down the vertebral column you go. So this is a pretty good figure showing all the minor and major differences between the three types of vertebra. Finally, we get to the sacrum and coccyx. The sacrum is actually a fusion of 5 sacral vertebrae, and this can take years, up to 20 years, for them to fully fuse together to form one sacrum. You'll notice there's a superior facet here. That's going to be for L5. So L5 is going to articulate with the sacrum superiorly. There's an area here called the sacral ala, and here, ala refers to this wing shape on the sacrum. So these are the sacral ala. There's also an articulation here for your hip, your coxal bone, or your hip bone, which we'll look at when we get to the pelvic girdle. Distal, or really inferior to the sacrum, is the coccyx, or tailbone. And you'll notice that it can be a fusion of many little vertebrae as well. This drawing shows 4 coccygeal vertebrae that have fused together to form the sacrum, or the coccyx, I'm sorry. The sacrum has holes in it, sacral foramen. And the sacrum also has a crest in the back, the median sacral crest. That is what the spinous processes have formed posterior. So that's the sacrum and the coccyx. The next video is going to kind of go back up the body and look at the sternum and ribs, which form the thoracic cage.